In today's class, we are going to see the topic representation of functions. So we can use, there are 4 types to represent the functions. Let us see one by one. A function may be represented by first one is set of ordered pairs. We all know how to write a set of ordered pairs. And the second form to represent a function is table form. And the third way of representing a function is in a arrow diagram. And the fourth way to represent a function is in a graphical form. We will see one by one. In that, the first one is set of ordered pairs. Set of ordered pairs can be represented as the set f is equals to x comma y such that y is equals to f of x. That is, y can be represented as f of x for every x in A is called set of ordered pairs. I will take 2 set and I will denote it in an example. We will consider a set x 1, 2, 3, 4. We will consider a set y 2, 4, 6, 8. So according to us, let us take 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6, 4 is mapped to 8. Let us denote this in a set of ordered pairs. Therefore, the function f can be expressed as 1 from x and 2 from y. So 1 comma 2. Similarly, we have to do it to the other numbers also. So 2 comma 4. That is 2 is mapped to 4. And the third set is 3 comma 6, which means 3 is mapped to 6. And the fourth set is 4 comma 8, which means 4 is mapped to 8. This is how we denote it in a set of ordered pairs. Next, we will move to the table form. And the second one, we are going to represent a function in a table form. Let us see how to represent it. And similarly, I am taking 2 sets. X is equals to 1, 2, 3, 4. And y is equals to 2, 4, 6, 8. And the function f is given as 1 comma 2, 2 comma 4, 3 comma 6, 4 comma 8. For the given set, this is the function represented. So we will take the f function to represent the function in a table form. So this is how we represent it. X, y, x has a set of values 1, 2, 3, 4. According to the function given, 1 is mapped to 2, 2 is from y. So 1 is mapped to 2, 2 is mapped to 4, 4 is from y. Next 3 is mapped to 6. 6 is from y, 4 is mapped to 8, 8 is from y. So this is the representation of a function in a table form. And the third one is, we represent a function by an arrow diagram. So I will show you how to represent an arrow diagram in a function. We will consider the same example which we consider for representing it in a table form. So x is equals to 1, 2, 3, 4. And we have y is equals to 2, 4, 6, 8. So the function we are given with is 1 comma 2, 2 comma 4, 3 comma 6, 4 comma 8. So let us do it in an arrow diagram. We will consider 2 sets x and y. X has a set of values 1, 2, 3, 4. And y has the set of values 2, 4, 6, 8. According to the function, 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6 and 4 is mapped to 8. So this is how we represent a function in an arrow diagram. We will move on to the next form, a graphical form. For this also I will consider the same example to represent the function in a graphical form. So fourth, we are going to represent in a graphical form. So we'll consider a graph. X-axis, Y-axis, 0, 1, 2, 3, 4, 5, 6, up to 6 I have taken, and along Y we have to take up to 8 because there are up to the number 8. 1, 2, 3, 4, 5, 6, 7 and 8. So we'll consider the function to draw a graphical form. So first pair represents 1, 2, which means this is the position of x and this is the position of y. Whereas in x-axis it is 1 and in y-axis it is 2. So we have to plot the point here at 1, 2. Next point is 2, 4. 2 at x and 4 at y. So it will come around here, which is 2, 4. Next pair is 3, 6. 3 at x and 6 at y. We have to plot it here 3, 6. Next fourth point is 4, 8. 4 at x-axis and 8 at y-axis. So it will come here 4, 8. Next we have to join the points we plotted in a graph. So this is how we represent a function in a graphical form. So in example 1.10, we are asked to find, using vertical line test, we have to determine which of the following curve represent a function. So before moving on to that, we must know what is meant by a vertical line test. Let us see that first. Vertical line test is defined as a curve in a graph represents a function if every vertical line intersect the curve in at most one point. So what does it mean is, in a vertical line test, a curve in a graph is given and it is used to find whether the given curve is a function or not. And how to find whether the given curve is a function or not is, if the given vertical line intersects the curve in at most one point, then it is called as a function, given curve. If it intersects more than one point, then it is called as not a function. Let us see one by one. So first curve, it is given like this and we are given with a vertical line. According to the vertical line test, the vertical line must intersect the curve in at most one point. If you see in this example, it intersects at 2 points, whereas it intersects the curve. The vertical line intersects the curve at this point and as well as at this point. Therefore, the given curve does not represent a function. Vertical line intersects at 2 points. P and Q, therefore it is not a function. We will move on to the second example. We will move on to the second subdivision. If you see, if you look at this subdivision, there are two vertical lines. We need not worry about this vertical line because it doesn't touch the curve at all. So we should only care about the vertical line over here. If you see this vertical line, it touches the given curve in at most one point. Therefore, the given curve is a function according to the vertical line test. The vertical line touches the curve at one point P. Therefore, the given curve is a function. We will move on to the third subdivision. Similarly, for this subdivision also, this is the given vertical line and this is the curve given. The vertical line touches the curve at 2 points P and Q. Therefore, this curve doesn't represent a function. And one more subdivision is given to find whether the curve represents a function or not according to the vertical line test. Let us check. So, how to do? We will use the help of vertical line test. Vertical line test, what does it say? A curve must touch the vertical line in at most one point. If it touches, then we call the given curve as a function. So, this is the vertical line given to us and this is the curve given in this problem. The vertical line touches the curve in at most only one point. Therefore, this given curve represents a function. In example 1.11, we are given with two sets A and B with a set of values. Then f is a mapping from A to B. B a given function given by f of x is equals to, f of x is given as 3x minus 1 and we have to represent this function in four types: arrow diagram, table form, set of ordered pairs and in a graphical form. So we are given with two sets A and B, but we don't know which value from A is mapped to which value in B. Let us find that. To find that, we are given with the function f of x is equals to 3x minus 1. So we will use that, we will find out and we will represent the function in four forms. So let us begin. How to start is, we will consider the function f of x equals to 3x minus 1 as equation 1. X value is nothing but the values in A. We will do one by one. So first I will consider 1. Value of x as 1. So substituting x as 1 on both sides. F of 1 is equals to 3 into 1 minus 1. 3 ones are 3 minus 1 which will give us 2. Which means the value 1 from A is mapped to 2 from B. So we have found out one mapping. And the second mapping we can find out the similar way by substituting the value of x as 2. So which means 3 into 2. Value of x is equals to 2. So 3 2s are 6 minus 1 which will give us 5. Therefore 2 is mapped to 5. Third one is we will substitute the value of x is equals to 3 as given. So 3 into 3 minus 1, 3 3s are 9 minus 1 which is 8. Therefore 3 is mapped to 8. Next we have to find for 4. Substituting the value of x is equals to 4, we get 3 into 4 minus 1, 12 minus 1 which is 11. Therefore 4 is mapped to 11. We have found out the functions. We will represent this as one by one. First we have to represent it by an arrow diagram. Let us see how to do that. Okay, we are given with two set of values A and B, and A as 1, 2, 3, 4, B as 2, 5, 8, 11, 12. According to the given function, we found out that 1 is mapped to 2. So 1 is mapped to 2, next 2 is mapped to 5, next 3 is mapped to 8, next 4 is mapped to 11. So this is how we represent it in an arrow diagram. We will move on to the second option. In a second option, we have to represent it in a table form. So let us do that. So set of values of x and y. I am considering A as x and B as y. Therefore, x values is 1, 2, 3, 4. Next, B values according to the function 1 is mapped to 2, 2 is mapped to 5, 3 is mapped to 8, 4 is mapped to 11. We need not mention the 12 in y value because it doesn't have any mapping. We will write the values only which has a mapping. And the third option is we have to represent it in a set of ordered pairs. So how to represent that? The function f can be represented as 1, 2, 2, 5, 3, 8 and 4, 11. So set of ordered pairs is also over. One more thing we are left out with is we have to represent it in a graphical form. X-axis, y-axis, x as 0, 1, 2, 3, 4, 5, 6, 7. Along y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have to map according to the function we found out. So what we have got is 1 from x is mapped to 2 in y. So along x axis it is 1 and along y axis it is 2. So we have to plot the point at 1, 2. And the second point is 2, 5. At x it is 2 and at y it is 5. So it is 2, 5. And the third point is 3, 8. At x it is 3 and at y it is 8. Therefore we have to plot accordingly at 3, 8. Fourth point is 4, 11. Along x it is 4 and along y it is 11. So it is 4, 11. We have to join all the points we have plotted in a graph, joining with a straight line. So this is the representation of a graph for the given function. Next we are going to see is types of functions. And functions are categorized into 4 types. First one is one-to-one function. Second one is many-to-one function. And the third one is on-to function. Fourth one is into function. See, we'll see one by one. First is one-to-one function. And one-to-one function is defined in a way: a function f is a mapping from A to B is called as one-to-one function if every distinct elements in A has every distinct elements in A must have distinct images in B. I will explain this more clearly with an example. I am considering the example which is given in the textbook, illustration 10. So we will consider the illustration 10 given in the textbook. We will find out how to say it is a one-to-one function or not. So set A is given as 1, 2, 3, 4 and the set B is given as A, B, C, D, E. Okay, so in a given function 1 is mapped to A, 2 is mapped to B, 3 is mapped to D and 4 is mapped to C. According to the definition, we will check whether this is a one-to-one function or not. It is a one-to-one function. How do I say is, every distinct elements in A has a distinct images in B. If you see, no two element in A is mapped to the same element, then it is called as a one-to-one function. Every distinct elements in A must have a distinct images in B. No two elements should have the same image. Then this is called as a one-to-one function. So we will consider one more function G, whether the given function is one-to-one or not. So set A is given as 1, 2, 3, 4 and the set B is given as A, B, C, D, E. We will map according to the given function G. 1 is mapped to B, 2 is also mapped to B, 3 is mapped to C, 4 is mapped to E. The given function is not one-to-one. How do I say is, the images, that is 1 and 2 are mapped to the same image B, which means G of 1 is also B, G of 2 is also B. Two elements have the same image. According to the definition, every distinct elements must have a distinct image. Therefore, this is not a one-to-one function. And the second type is many-to-one function. Whereas many to one function is defined as a function f is a mapping from A to B is called many to one function if two or more elements in A has the same image in B. Has the same image in B. So let us see this with an example. We will consider the example given in the textbook. Illustration 11. So we have considered the given example in the textbook. Let us find this is a many to one function or not. The set A is given as 1, 2, 3, 4 and the set B is given as A, B, C. According to the function f, 1 is mapped to A, 2 is mapped to A, 3 is mapped to B and 4 is mapped to C. If you see in this arrow diagram, two elements from A, that is 1 and 2 have the same image A in B. Therefore, this is called as a many to one function because many to one function defined as two or more elements in A has the same image in B. That is f of 1 and f of 2 both has the image A. Therefore, the given is a many to one function. In simple words, we can say a function is many to one if it is not one to one. Simply we can say that if it is not a one to one function, then it is called as a many to one function. And one more thing I wanted to say is one to one function is also called as injection. One to one function is also called as injection. And the third one we are going to see is an onto function. Let us see what it is. A function f is a mapping from A to B is called as onto function if the range of f is equal to the codomain of f, then it is called as an onto function. So let us see this with an example. That is, range of f must be equal to the codomain of f, then it is said to be an onto function. We will see it with an example. We will consider this example. We are given with two sets A and B. A is given as x, y, z and B is given as L, M, N. According to the given function, we will map this function. X is mapped to M, Y is mapped to N and Z is mapped to L. According to the onto function, the range of f must be equal to the codomain of f. Codomain means the elements in the set B, we call it as a codomain, and the elements which has a pre-image, we call it as a range. According to this function, range is equals to, which means L as a mapping, M as a mapping, N as a mapping. So range f is equals to L, M, N, whereas codomain for this function will also be L, M, N. What I mean to say is, no element in B is without a pre-image. Every element in B has a pre-image, which means that it is said to be as an onto function. An onto function is also called as surjection. Onto function is also called as surjection. And the fourth type we are going to see is an into function. A function f is a mapping from A to B is called an into function if there exist at least one element in B which is not the image of any element in A. Okay, so let us see this with an example. We will consider the example which is given in the textbook, illustration 13. So set A is given as 1, 2, 3 and the set B is given as W, X, Y, Z. We will map the function according to the given F value. 1 is mapped to W, 2 is mapped to Z and 3 is mapped to X. If you see in this function, the set B, Y is not an image of any of the element in A, which means Y doesn't have a pre-image. Therefore, this is called as an into function. There should be at least one element which is not the image of any element of A. Then this is called as an into function. So these are all the 4 types of functions. So next is bijection. Let us see what is bijection is. A function f is a mapping from A to B is called as bijection if it is both one-to-one and onto. So whether the function, if it is one-to-one and onto, then we call it as a bijection. One-to-one and onto in the sense it is injection and surjection, because one-to-one is called as injection and onto function is called as surjection. Bijection is both injection and surjection, which means one-to-one and onto. If a given function satisfies these both conditions, then we call it as a bijection. So let us see an example for this. Is this a function is a bijection or not? Let us see. According to the bijection, it should be one-to-one and onto. This is a one-to-one function because 1 as a image W, 2 as a image Z, 3 as a image X. For every distinct elements in A has a distinct images. So one-to-one condition is satisfied. Next, the range of F is equal to the codomain of F, which means there is no element which is not of a image. Therefore, this is onto function as well. It is a bijection. If it satisfies both one-to-one and onto, then it is called as a bijection. Let us see one more example in this. So 1 is mapped to A, 2 is mapped to D, 3 is mapped to B, 4 is mapped to C. Whether we will check whether this is a bijection or not. This is not a bijection. How do I say is, it is an injection, which means it is one-to-one function. Every distinct elements has a different distinct images, but it is not onto. Why do I say it is not onto is, whereas E and F in B doesn't have a pre-image. Therefore, this is not an onto function. It is not a bijection as well. It should satisfy both one-to-one and onto. If it doesn't satisfy any one of one-to-one or onto, then it is called as not a bijection.